In this video, we're going to construct the binomial option pricing model. If you don't have this worksheet, it's provided for you on the Moodle site. You need to go and download the binomial pricing model worksheet that has this information provided for you. If you don't have access to that, then you'll have to construct something like this in Excel. You can leave the formulas out. Just look at those on the screen. They're just for student reference as you build the equations. There are some assumptions provided in our problem. We're going to replicate a portfolio. In order to do that, we're going to take a position in a stock at a given share price, and we've selected the initial stock price of $50. We're going to then take a position in a risk-free bond at a given risk-free rate, and we've decided to purchase a hypothetical bond at $1 at a risk-free rate of 6%. We've set the exercise price at $55, and we have decided that the probability of the upstate, in other words, things going up, is 10%, and that the probability of the downstate is 3%. And notice that we've stated the downstate as a negative value, negative 0.03. Now we need to calculate the probability of state up, or Q sub U, and the probability of state down, or Q sub D. We have the formulas here. Q sub U equals R minus D over 1 plus R times U minus D. So let's go ahead then and construct that equation. We'll go ahead and equals. We want the numerator first, so I'll get that quantity. It's going to be R minus D over the quantity 1 plus R times the quantity U minus D. That gives me the probability of the state up, which is 0.65312. Now we'll calculate the probability of state down. First we'll get the numerator equals U minus R. There's the numerator, divided by, get the denominator, 1 plus R, that quantity, times U minus D, that quantity. Now we have the denominator, that is 0.29028. Now we have the probability of state up, or Q sub U, and the probability of state down, Q sub D. Next, we calculate our two matrices. We have a stock price matrix and a bond price matrix. Now, we'll calculate the bond price matrix in this exercise, although in the models that we're doing in this course, we're not going to use the bond price matrix in any of the calculations. However, it is a part of the binomial option pricing model and is used in different scenarios, so you should be able to calculate it. It's fairly straightforward. Let's do the stock price matrix first. We'll set our initial stock price equals our initial stock price there, so we can change our model if need be. Then we have a formula for the upstate. The current stock price equals the preceding stock price times 1 plus the up percentage, and we're going to make that absolute because we can copy this to all of the up sides. If I just do a Control C, or if I right click here and select copy, either way, I can go here and do a Control V and paste that value, then a Control V and paste that value, and a Control V and paste that value, and that will give me all of my upside pricing. Now do my downside pricing the same way. The current stock price equals the previous stock price times 1 plus D, the downside. We need to make the D absolute, so that as we copy it, it looks to the right number. And as with the upside, we can do a Control C and just copy it with a Control V and a Control V and a Control V to all of the downside pricing. We have that. For the rest of the prices, because of the way we entered the relative and absolute cell references, we can go ahead and select, for example, any of the upside prices. I'll just go ahead and use upside, copy that, and now I can paste it with a Control V to all of these other cells. And I have the model completed. Let's do the bond pricing. And the bond that we decided to purchase, we're just going to set it at 1. And we'll create our model. The current bond price equals the previous bond price times quantity 1 plus and R, which is the risk-free interest rate. We'll make that absolute so we can copy this and speed this process up a little bit. All right, here's the upside scenario. I can just do a Control C and copy that and paste it to all of the upside scenarios. Now I'll calculate the downside scenario. The current bond price equals the previous bond price times the quantity 1 plus risk-free interest rate. And why is upside the same as downside? The key here is risk-free interest rate. This is how the bond's going to perform. It's a risk-free bond. So we'll copy that, Control C, and then we'll paste it, Control V, Control V, Control V. Then we can copy any of our upstates and just paste them in these remaining cells, Control V, Control V, Control V, 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 Control V. You can see the pricing is fairly uniform in the risk-free bond price matrix. Now to calculate the American call option, let's go ahead and just scroll up to get the American call option in here. I'm going to take the max, the current stock price, minus the exercise price. We'll have to scroll up a little bit to get to that. And we'll make that absolute. Once we have that value, we will take the larger of that value or 0. So if it's a negative value, if the price of the stock in the current period is less than the exercise price, then who would want to buy the call option? They just go ahead and buy the stock that's already cheaper than the exercise price. So it's worthless at that point, so it would be 0. Otherwise, there's some value and we'll calculate that value. Now, because we've used absolute and relative correctly, we can go ahead and copy this, Control C, and copy this down to each of these, Control V, Control V, Control V. All right, for period 2, let's calculate the call option price. And we have to remember the difference between the American call option and the European call option. The American call option can be called at any period, at any time. So when we calculate the American call option price for each period, we have to check to see if the difference between the current stock price and the exercise price is a better deal than the price that results from the call option formula. Otherwise, we create an arbitrage situation where investors can make money just buying our call option. We don't want to do that. So let's do this calculation. There's our formula right here. We'll take the max of the max of our current price less the exercise price, which again we'll go up and get. We'll make that absolute, and 0. We've solved that nested max statement. Now let's solve for the parent max statement. We have the first value. The second value, we'll go ahead and calculate the call option. Now the call option price is our previous price times the probability of the upstate. We'll make that absolute. Plus the downstate. Excel's in our way here, so I'm just going to put my cursor here and move up one. Gets me to F27 times the probability of the downstate. And make that absolute. And then I'll close that max statement. Press Enter. Now, because I used proper cell referencing, I can move my cursor here and just copy with Control C this value and then paste it, working backwards throughout the sheet. And that will give me my values for the American call option price. So my current American call option price is $6.8180. Let's go ahead then and do the European call option, which is very similar to the American call option. It's just that we don't have to include the stock price and exercise price comparison all the time. So we'll go ahead and start at the back and work forward. We'll take the max of the current stock price, leave that relative, minus the exercise price, which is here, make that absolute, or 0, whichever is greater. Then I can just copy that, Control C, and do all of my final period calculations here. Control V, Control V, Control V, Control V. And I'll go ahead and calculate the European call option, which again is just the call option calculation. That's going to be the upstate price times the state up probability. I'll make that absolute, plus the downstate price times downstate probability, make that absolute, press enter. And once I've done that, again with proper relative and absolute cell referencing, I can just copy that, working backwards, paste it throughout the model, and it will calculate the European call option price for each period. And you can see in this model that the American call option and European call option prices are the same. And that's how you set up the binomial American call and European call option models.